After finishing up exercise 1 and 2, we're going to go to exercise 3, which is using EMG to study gait and to understand the muscle function during gait. This one is a little bit hard, and it'll involve some gait analysis, but you'll learn a lot after this one, I think. So that's an example. Like they put electrodes on tibialis anterior and gastrocnemius, and that they have the guy walk. So he's going to walk, and then they use the harness to unload the body weight 50%. So they study gastrocnemius and tibialis anterior muscle activation pattern during walking with normal body weight load and 50% body weight unloaded. And you can see for gastrocnemius, the activation amplitude just decreased, and that's obvious, right? But for tibialis anterior, I would say that muscle activation didn't change much in terms of the amplitude. And even though you see like it seems a little bit higher, but it's hard to tell. So I would say it remains the same. But why does the different muscle has different characteristic when the body weight is unloaded? One is decreased, one didn't change. Why does that happen? Think about it, and then we need to go to gait cycle to understand the function of each muscle during the gait cycle. So in this gait cycle, we're looking at this a little bit darker color leg. So it's separated into two phases. The first one is stance phase. Second is swing phase. How do we determine if it's stance phase or swing phase? It's pretty easy to see if the foot is contacting with the floor. So during stance phase, the foot should be on the floor. So you can see for this darker stick, it's here, 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 here. It's all contacting with the floor. So that's stance phase. And then after the foot is taking off in the air, it's not contacting with the floor, right? So that's swing phase until the second contact here. So that's pretty easy to see if the foot is contacting with the floor to determine if it's stance phase or swing phase. And in normal gait cycle, stance phase should consist of 60% of gait cycle and swing phase for 40%. That's for normal walking. And then look at deeper into stance phase. There are several sub-phases. So the first one is initial contact. That's when the heel is contacting with the floor. And then with the loading response, that means you transfer your body weight from this leg to the leg just contact with the floor. So that leg can take off later. So that's the loading response with this darker leg. And then with mid stance, terminal stance, and pre-swing. And also we can divide those phases, sub-phases into two other subphases. That would be double support or single support. And those are also pretty easy. Double support means your two legs are both on the floor. And single support is that means only the stance leg is on the floor. So for double support, you can see those two feet are on the floor. That's initial contact and loading response. And after loading, the contralateral leg will take off in the air to go into swing phase. So after the contralateral leg go into swing phase, that's single support because only the stance leg is contacting with the floor. And those stance and swing phase are separated by toe off. Alright, makes sense? Then we can think about what's the functional role of gastrocnemius and tibialis anterior. That's the typical EMG response for gastrocnemius or your calf muscle and tibialis anterior. So let's take a look at the loading response. That's when your heel is contacting with the floor. And you can see actually the tibialis anterior is activated in this phase. Why does that happen? Think about it and we'll talk about it later. And then during a stance phase, like most of the stance phase, gastrocnemius is activated. That makes sense, right? That gastrocnemius is here, the calf muscle, should support the body weight and also propel yourself forward. So that's your calf muscle activating during the most of the stance phase, except for the loading response. And then for pre-swing and the swing phase, your tibialis anterior is activated because in the swing phase, your tibialis anterior is bringing your foot up to facilitate ground clearance. So this supporting your foot segment. So in the stance phase, gastrocnemius is important. It'll support your body weight and propel yourself forward. And then after toe off, your tibialis anterior will activate it to bring your foot segment up to facilitate ground clearance. Okay, then why does tibialis anterior activate it in the loading response? And I'm not sure. I remember that's probably one of the question, one of the scenario in exercise 1. I remember. I'm not quite sure, but you'll figure out it right now. So think about it during loading response, and if there is no muscle activation, here is a axis of rotation. That's your heel, and your body weight is transferred from the tibia, right, to your foot segment. You can see there is a moment arm. So actually your body weight is trying to force your foot segment to slam the floor. But then if the tibialis anterior is not activated, then you're going to slap the floor, right, during initial response. That's not what we want to, and that's not what we normally walk, right? So actually tibialis anterior is providing another force here, try to decelerate your foot segment so your foot can go contact with the floor lightly or softly. So you're not slapping the floor, you're contacting with it during a controlled motion, and you're softly contacting with the floor. So that's why tibialis anterior is activated during the initial contact or the loading response phase. Okay, so you probably want, maybe some of you want to go back to exercise 1 to change your answer. Yeah, so we'll talk about the questions in our next video.